Right, ladies and gentlemen, this will be the last of our radioactive decay lecture, and that's basically an example of applying the activity of carbon-14 to something a little more realistic. So, example 10.6. Archaeologists find only 80% of the original carbon-14. Make this a little smaller. How old is the wood if only 80% of the original carbon-14 remains in the sample? First thing to remember is the initial activity of carbon-14 is 250 becquerel, or 6.76 times 10 to the minus 9 curie. So what does this thing mean, 80% of the original? Well, if you think about it, 80% of the original C14 means 80% of N0. If you think about it, does that make sense? 80% of the original C14 remains. Well, N0 is original number of C14 nuclei. So then N is equal to 80% of N0. Just like that. Okay, well, what involves N and N0? We have the decay law. So actually, when you get to this point, you know this information, the rest is pretty straightforward. How old is the wood? That's what we want, T. How old is the wood? We know how N and N0 relate, and we know lambda inadvertently. Let's just remember. Lambda is 0.694 over the half-life. And that half-life is 5730 years. And we did this it's 0.693, by the way. Let's fix that. Lambda equals 0.693 over the half-life, 5730 years. Right? Okay. I'm going to leave it in years, because why not? We're going to get the answer in years, and that sounds good to me. So N equals 0.80N0. This also means N over N0 is just 0.8. And so here, taking this, N over N0 is just your exponential. So 0.80 equals e to the minus lambda t. How do we isolate t? We take the natural log of both sides. We get natural log of 0.8 is equal to the ln of e to the minus lambda t, or just minus lambda t. Solve for t. get -1 over lambda times ln of 0.8. Right, insert what we know for lambda, ln of 0.8 over 0.693 over 57 30 years. Make the fraction less complicated, solve it, and you get 1,845 years. The book points out that it can be plus or minus 5%, so it could be plus or minus 150, 200 years. But this is basically what happens with carbon-14 dating, is that you need to know how much C14 relative to C12 is in the sample, and assume you know its initial activity, or the initial ratio of C14 to C12 as that 1.3 times 10 to the minus 12 factor. Anyway, that is it, and that ends our lesson on radioactive decay.